All right, let's just jump right in. What if I told you that you could make armor that's more like a coat of paint than a heavy metal plate? Sounds crazy, right? Well, today we're diving into a material that's so strong, so incredibly thin, and so versatile, it's on the verge of doing exactly that. I know, it's a wild idea, but just think about it. A coating this advanced could shield a vehicle from impacts, from corrosion, even from electronic interference. And yeah, while it definitely sounds like something straight out of science fiction, this is quickly, and I mean quickly, becoming a reality. Okay, so here's our game plan for today. First, we'll talk about the long-running quest for perfect armor. Then, we'll meet our star of the show, graphene. We're going to unpack its triple threat properties, see how we actually unlock its full potential, and finally, take a peek at what a graphene-coated future might look like. So for decades, engineers have been stuck with this fundamental trade-off, right? If you want to make something tougher, you almost always have to make it heavier. And in really high-stakes situations, like with armored vehicles, adding all that weight is a huge problem. It kills mobility, it reduces what you can carry. The holy grail has always been to find a material that just completely breaks that rule.
And that's where our hero material steps onto the stage. You see, graphene isn't just some small improvement on what we already have. No, it's a fundamental game changer. It's offering a real solution to this age-old engineering puzzle.
So what exactly is this stuff?
Well, at its core, graphene is just beautifully simple. Imagine a sheet of carbon that is only one single atom thick. Let that sink in. It's arranged in this perfect honeycomb pattern, a perfect lattice. And that unique, flat, two-dimensional structure, that's the secret sauce. That's where all of its superpowers come from.
And when you put it up against what we use now, the difference is night and day. Your typical coatings, they can be heavy, kind of brittle, and usually they only do one job. But graphene-based coatings, whoa, they're incredibly strong, super flexible, almost weightless, and they can do a bunch of things at once. It's not a step forward, it's a massive leap. Okay, let's get to the good stuff. Why is graphene so special? What's all the hype about? Well, it really boils down to this amazing combination of three key properties, a real triple threat that makes it unlike anything else we've ever worked with. First up, we've got its sheer, almost unbelievable physical strength. Really try to wrap your head around this. We're talking about a material that is stronger than steel, but at the same time, it's incredibly lightweight and flexible. It just doesn't seem possible. So, what does that mean in the real world? Well, it means it's extremely difficult to stretch or break it. That's its amazing tensile strength and stiffness in action. But here's the kicker. It's not brittle. It can actually take a hit, absorb the energy, and bend without shattering. And it does all of this while adding practically zero weight to whatever it's protecting. All right, superpower number 2. We're shifting gears from pure physical strength to how it handles energy. You see, graphene is an exceptional conductor of both heat and electricity, and that property, on itself, is a massive protective feature.
And this isn't just some passive thing. It actively works to pull heat away from hotspots, which cuts down on the thermal stress that can weaken materials over time. Plus, it can create a kind of shield against electromagnetic interference, to protect all the sensitive electronics packed inside modern vehicles and gear. Super important.
And that brings us to the third and final superpower, its ability to create a nearly perfect barrier. Think about it. At an atomic level, the structure of graphene is so dense that almost nothing, and I mean nothing, can get through it. It's like an impenetrable wall for tiny molecules. So here's how it works in a coating. When you mix these tiny graphene flakes in, they overlap and create this microscopic maze. So for a little molecule of water or oxygen trying to get to the metal underneath, forget about it. It's like trying to navigate an impossibly complex, winding labyrinth with no exit. So the result? You get a coating that completely blocks all the things that cause corrosion, which dramatically extends the life of the material. But it doesn't stop there. It also helps spread out the energy from impacts and general wear and tear, which means less damage over time. It's just a win-win. Okay, so we've seen what graphene can do, which is amazing. But how do you actually turn this one atom-thick sheet into a tough, practical coating you can actually use? Well, the process for doing that is just as cool and innovative as the material itself. It really boils down to a 3-step process. First, scientists create different forms of graphene, like these tiny little flakes called nanoplatelets. Second, they functionalize them. That's a fancy word, but it just means they chemically tweak the surface, attaching specific molecules to help them grab onto and mix well with other materials. And then finally, they mix these specialized little particles into a host material, a matrix, which could be anything from a polymer to a metal to a ceramic. And just look at the results. It's incredible. You add it to polymers and boom, you get a huge boost in strength and heat resistance. Mix it into metals and you get alloys that are way harder and more resistant to wear. Put it in ceramics and it creates this amazing shield against environmental damage. Graphene is like this universal upgrade for pretty much anything you add it to. And this all brings us to the future, because when you put all of these properties together, you realize you haven't just made a better coating. No, you've created a single, thin layer that can do multiple, really complex jobs all at the same time. It's a multifunctional platform. Think about this. A single graphene-enhanced coating can give you ballistic protection from impacts. It can stop rust in its tracks. It can act as a self-lubricant for moving parts. It can prevent ice from building up. And it can shield sensitive electronics. All of that in one thin layer. That's a level of efficiency and integration that is just totally unprecedented. So, really, the big takeaway here is this. We are moving way beyond just passive protection. Graphene isn't just a stronger shield. It's the foundation for creating surfaces that are intelligent, that are active, surfaces that can actually respond to whatever their environment throws at them in real time. I mean, graphene is already starting to revolutionize everything from military hardware to our everyday consumer electronics. So the real question we're left with is, with a material this powerful, what's it going to redefine next?